Hey guys, in this video I'm going to show you how you can create this abstract cool looking animation. This is real time and it's running on the web. We're going to be using ThreeJS and I'm going to show you some cool things we can do with shaders and post-processing. And as you can see, I can change these values and the shader changes in real time. So if you're new to this channel and you want to learn some tips and tricks on how you can build real-time 3D experiences on the web, subscribe to my channel and ring the bell icon so you don't miss any future videos. With that being said, let's get started. Okay, so this project is inspired by this artwork from Ducky 3D. He has done a video tutorial on this and I'll put the link to his tutorial in the description. This is done in Blender and we're going to basically try to replicate this. And in my opinion, one of the best ways that you can learn shaders is by copying good art. And even better, you can copy the entire process of creating good art with video tutorials like these. So without further ado, let's get into it. So here inside Blender, I have this scene opened. If you follow along with the Ducky 3D's tutorial, you're going to get something like this. Now, if we disable the displacement modifier, you're going to get a simple torus shape, basic donut-like shape. So let's start with that. Here inside VS Code, I have this starter repo opened. I'll put the link to this repo in the description, so you can start with the same files as me. And if we go into app.js in src folder, we have some basics boilerplate code. So here we call the init function, which initializes the scene, camera, things like that. And we have a torus here defined with a shader material and vertex shader and fragment shader. And we just add that torus to the scene. And that's basically it. Now, if you run this, you're going to get this, a simple blue boring torus. So we're going to make this look cool. So if I go back here, here inside the fragment shader and vertex shader, let's see what we have. So inside the vertex shader, we have some boilerplate code, which I've placed. So this is basically Perlin noise implementation in GLSL. We're going to use Perlin noise to create some of those effects with the displacement. But I haven't actually used it anywhere. It's just placed there. So we have this vector called displacement, which is set to 0 here, and we'll multiply that by the normal. We add that to the position and we get our new position. So that's basically it. It's just some boilerplate code which we use for getting that torus. And inside our fragment shader here, we have a very simple color defined here. So nothing complicated. And we're just passing these varyings from the vertex shader to the fragment shader. It's v position, vuv, v normal, and this is just an extra varying which I created, but that doesn't matter. So let's first create a variable called pattern. Let's go ahead and visualize vPosition.x, for example. Let's just see some things. Let's just visualize. So we have to replace pattern here. And we get something like this, which is already pretty cool. And I think we can maybe use this to actually displace the place that we want. So let's go ahead and check another variable. Let's see vuv.x. Let's check the UVs, see if that can help us. And this is somewhat better because it goes from 0 to 1, and we kind of have full control over where we want to place things. So we might just use this variable. Let's see. So the problem here is that we have a hard transition there. It goes from 0 all the way to 1 here, but we want this to be smooth. So if you go back here, we subtract 0.5. Let's see what we get. We now get minus 0.5 here, all the way to, I think, 0 here, and all the way to 0.5 again here. So it's very simple, but let's use an abs. First, let's close this. Yep. Let's use an abs around this. Let's see what we get. Okay, so we get the result that we want. pretty much. So it goes from 0.5 all the way to 0, all the way to 0.5 here. So if we multiply this by 2, and now we get this. All the values go from 0 all the way to 1 here. So it's very simple, but let's try to reduce the amount of areas that are white. Let's just try to focus on a single area, a small area, like the reference that we have. So our reference all the way here, the displacement is 0, but here the displacement is transitioning into 1, and this is the peak. So let's try to replicate that. If we go into here, and let's just experiment with some things, right? If I add some amount to this, what will happen? Okay, we get more white. That's obviously not what we want. Let's subtract 0.4. Oh, and we get something that looks like something that we would like. So we're getting the smooth transition here, but the values here are not 1, right? So let's first of all change this to 0.3. I think that would look nicer. Yep, this. And let's now multiply this by something more than 2. Let's just do 0.3. This is gonna go above 1. It might go above 1 in some cases, but we can just use a clamp. And in the fragment shader, it automatically clamps everything to 0 and 1. So we're not gonna worry about that just yet. And there we go. It's starting to look like something that we want. It's all the way 0 here, and we smoothly start to transition here to something that looks like 1. Now, can we actually do a multiply by 4? Is my question. It's pretty much the same. So let's just keep it at 3. And let's just put a clamp all around this. So, by the way, 0.f means float. If you didn't know, it's the same as a simple 0, basically. That looks nicer. So, yeah, we have the clamp. We don't have to worry about anything, and I think we're just ready to do our displacement here. So let's just copy paste this pattern to our vertex shader. Let's go in here. Yep, and let's call this noise multiplier, because that's what it does. So and we can use this to displace everything. Now, what we want to displace is a noise value. So let's call this new variable noise. Let's use the p noise, and let's pass in the position. V position. I think this takes a wig 3. Yep. Returns a float. It's as simple as that, and let's just try to do this. Displacement equals noise multiplied by noise multiplier. It's as simple as that. Let's fix our fragment shader here, because we don't have this pattern anymore. Let's just set this to 1 for now. So yeah, let's see what we get. We get nothing. We get an error probably. Yep, because this is a vec3, it should be a float, and yeah, I think that would fix everything. Yup. If we go back, we can see the area that we want is displaced now, but the noise scale is too high. So let's multiply this by a higher number, and you can see we get the exact same results that we want, exactly like this. But this is kind of low poly, and we need to increase the poly count to get a smoother effect. Let's multiply this by 5. Yeah, and we get a much nicer result. So I think it's time for us to move into the fragment shader. And if you look at the final result of this, if I go into render mode, we have this nice shading, nice noisy shading, which matches the geo and the noise of these areas. So let's learn how we can create this. So if we go into the shading tab, we have this massive node setup here. But all this does basically is it gets a vector from the object and it separates the Z. So we're just using the Z component. It uses that Z in this function, in the noise function, and it uses a color ramp to make it look nicer. And basically, it basically adds that factor, a noise factor, as a bump map and as the base color. So that's basically what it does. So let's try to implement this base color noise functionality here. So if we go into here, we can pass the displacement value from here to the fragment shader. So yeah, let's just do v pattern equals noise multiplier. We can call it v noise multiplier, but I think this is fine. Let's do a vec3 here. I'm just gonna do some basic experimentations. Let's make sure we have v pattern here. We don't. Let's use a vec3 v pattern. Okay, so yeah, we can now use this. We can visualize it, and it's the same thing that we have, right? So it's not helping us much. Let's see what we can do here. I think we would need the noise function in the fragment shader as well. So I'm gonna just copy and paste this into our fragment shader as well. Copy and paste the parallel noise implementation. So this vector, I think it comes from the object, which is the position in our case. Let's use that as the input to the noise texture. So let's create a new variable here called noise equals pnoise v position, and here it is only using the Z component of the position. Let's do the same thing. Z, we have to wrap this in a vec3. And what will we get? Nothing, because we're not using the noise value. Very interesting. So, yup, here's the effect that we wanted. So let's multiply this by something more. And it is exactly the same effect that we wanted. Now, we have to go here, disable wireframe. Let's just remove it. Yep. And yeah, we get this nice effect. Let's also increase the poly count. So it is 100 here. It needs to be like 1,000. And we get this. So it's pretty cool. It's looking the exact same way that we want it. We just need to do some color multiplication or something to make this look nice. So let's go into the fragment shader, and let's just do vec3 color, and let's just copy paste this here. So here we want to multiply this by a nice value. Let me just copy paste this. I already have the values. Yeah, so I can just paste this purple color here, and we can just use this to color the torus. Pass in color here, and we get this. which is pretty cool. But we can make this way cooler by some post-processing. So let's go into app.js. I'm just gonna copy paste some code that I already have with these parameters. I'm gonna just create a balloon pass and just pass it to the composer like this. So let's see what we get. And we get this, which is pretty cool if you ask me. Now we can make this cooler. We can add some animations here. Let's go into the vertex shader, and we have this uTime uniform that I set here in the animate function. So just FYI, we're going to use this uTime to animate. So what we're going to do is basically, we can add the uTime here, I believe. We can do plus sign of uTime. I think that should work. So let's see what we get here. And we get this, which is a pretty cool animation. And you can add some controls here to make it even cooler. Change the animation, change the noise parameters, things like that. And to be honest, this code is not exactly the same code as the demo I showed you earlier, because I just don't memorize these things. I just experiment and I try to see what I can get with the parameters I have. Experimentation is very important, but you just have to know how to experiment. And with more experience, you're going to learn how to actually use some of these parameters to get the effect that you want. I'm going to do more tutorials on shaders, so stay tuned for that. And if you play around with the values and some of the noises and play with some parameters, you can get some pretty cool results like this one that I showed in the beginning of the video. I'll put the link to the code of this in the description. So if you enjoyed this video, hit that like button, subscribe to my channel, and ring the bell icon so you don't miss any future videos. And on that note, I'll see you guys next time.